So good to be here. Thank you, everybody, for joining. My name is Shaf Sayed. I'm one of the principal architects at Red Hat. I work very close to the product development units and providing feedback input there into more developer experience in terms of cloud native solutions, whether they're telco, whether they're any specific industry. And today, I'm happy to talk about Edge and OpenShift AI and how these two map together. And I'll take you through that journey and obviously looking forward to some interesting questions as we go along. So if you're looking into Edge, if you know about Edge, I mean, Edge is not something extremely new as a word, but together with Edge, as you use it in your telecom networks, if you are adding artificial intelligence, which I think throughout the day you probably hear most about, gives certain opportunities when it comes to increasing the services towards the network edge, enhancing the customer experience, enhancing the internal development experience, connectivity, etc. All of these sort of are awesome edge features when you start to mesh them together with AI. But once we say all of this nice stuff, we also realize that there are things that needs to be taken care of. For example, security and compliance, and how do you manage your zero trust applications, and how can we bring in partner related apps, for example, or solutions into this, and obviously the connectivity. All of these things sort of bring this mesh together and start to make things a little bit more complex. So how is it that we can actually streamline this experience and ensure that you can continue working towards the edge, as well as ensuring that you are having artificial intelligence not just being embedded into certain parts of the solution, but all those parts of solutions, and having the possibility from the edge to be able to speak to central systems or edge systems, etc. I'm going to highlight some of those today and hopefully have this interesting discussion. When we take the second step of saying, yes, we want to do edge and AI, obviously, there are different use cases that we should think about, things that we do, for example, ensuring that there is data that we can analyze on that will accelerate our decisions. That could be in-vehicle systems or maybe data coming in from a video device, etc. There's tons of these things out there. So how can we improve our decision making faster? What about enhanced user experience when we have different applications that are out in the retail, as an example, in maybe in a shop, when a user when a customer just comes into a shop or a specific warehouse, and they are going towards a certain direction, and how do we actually ensure that that particular person has certain interests and link them up to our system, and then obviously listen to those events and be able to react upon them, as an example, or even having remote operations. And more importantly, I think having data and compliance, where you have a process to manage the data that you are mining and the data that you're sending and the data that is being prepared, etc., but also locality of the data, cross borders, regulations, all these different things, they start to take that shape. And obviously that this sort of helps us to classify the different use cases that we have when we start to work with edge and AI, as an example. So obviously there could be a little bit more classifications around it, but these are the broader terms as I would put them. When we're looking towards the readiness, in my presentation, I'm looking at a solution where we are looking at one platform, a platform that will help us to build these building blocks together and ensure that we are able to have that scalability, security with the agility that we are talking about, and in enhancing that experience when it comes to edge, when you're rolling out your solutions. Are they secure? Are they trusted, etc.? All of those things. But then also, how does data science look for developers? Because obviously things change, and as we work with models and retrain them, as we continuously do that, how can developers leverage that and at the same time use those models within their applications? What sort of tool sets can we look into as well? And then further, obviously, automation and end-to-end automation use case, where we can say, yes, we have a container that needs to be rolled out to almost to the far edge. How do we do that? And what kind of practices do we do? So I will discuss them as well in this presentation. And obviously, the last part, which is important, is the partner ecosystem that we are able to integrate and work with as well. So 4 different areas where we would say that, we need readiness to adopt to edge and AI together, and how that would look. So before I go forward, I mean, this is a typical edge network diagram that we see. We have a core data center, we have the edge distributed, and then obviously the far edge. And we have different, sort of workloads or functions that are based out of these different boundaries. And that's what we know of as of today when we look at it. And when we are looking at it, obviously from the most furthest on the left, we have hardware and software that is limited, obviously based on certain restrictions of the hardware. The software is also limited, but more interestingly is how do we actually end up managing the life cycle of these resources. They're hard to reach locations. Connectivity can be an issue. How does that manage together? And then obviously some of these would scale. And let's say if we have a farming use case, we would be, putting a lot of devices out there in different landscapes, etc., and different positions to ensure that we have the right kind of data that we need to operate. And obviously that brings in some challenges with not just scale, but also security and ensuring the consistency of the solutions as well. When we look at a device edge platform on the most furthest part of the edge, obviously, we're looking at a hardware spec, which is maybe 1 core or 2 cores at max, right? And has maybe a little bit of memory, like 2 GB as an example. So it's extremely minimum requirements of what can be done and operated. In that case, obviously, something like Red Hat Enterprise Linux or the device edge platform, you just use the operating system as bare as possible to be loaded, or an extremely minimal amount of containers that you would use. The other, the more further we come in, we have the single node edge servers, and in that case, you would have servers that maybe have a little bit more memory and cores, and use cases where maybe certain use cases with functions like VNG, etc., could be supported as well, or maybe even remote worker nodes, which have more cores to them as well as memory as to be able to do this. And then finally, into a more centralized structure where you could have your clouds and decentralized data centers, etc., all of them together, kind of have a bigger setup. And at that point, so 3 node clusters would also do in that situation. So the flavoring of these is possible as of today's technology, and the distribution of these is possible as of today's technology. And these specs sort of kind of give us the possibility that we can have multiple workloads that we can run on our edge platforms. For example, on the most furthest side on the left, we can use the IoT data collection of gateways, machine vision, point of sale systems, whereas on the single node, we can go into more towards field operations like in-vehicle, and single server operations, even disconnected environments, being able to create that mesh of networks together. And then finally, towards a little bit more beefy software, which is a good enough network required, where workers can run RAN use cases, etc., or visual inspection, or something that needs more power and connectivity at that time can also be used. And then towards a 3-node cluster where you're having a little bit more space to you, you're able to do artificial intelligence, smart manufacturing, etc., and obviously disconnected cluster environments as well. So it sort of helps to have those different use cases when we start to pan out how artificial intelligence, AI, as we say, would sit into this landscape. When we're looking at all of this, which I just spoke about, is the conceptual architecture is you're looking at stream processing, events coming into a certain stream. You're looking at flow management in terms of not just your network, but also all the events and system messages that are coming in. And then finally, what you also need is an AI-powered application that actually uses what AI is being building, for example, or the models that are being used. And then finally, edge management to ensure that you have and encompass all of that. There is this workflow that you're looking at, which is your software applications and your data pipeline together, ensuring even adding security to ensure that you have a continuous pipeline to run and deploy applications at scale on the edge. Obviously, you also want to develop. So if you move towards the right, you also want to develop your model and retrain your model, analyze the data that's coming in, reload that into your system, retrain your data classification, or in case of unsupervised learning as well, you're able to bring all of that together. And it's important that there's a process to that as well. And when we look at how OpenShift or AI together with Edge kind of meshes together, we want to bring both of these use cases together closer to have a more operational and a good experience, not just for infrastructure ops, but also for developers. So again, in case of whether can we deploy artificial intelligence towards the edge? Can we have a system that is so beefy that can actually do something like this? We obviously can divide the components of AI in itself. When we look at the core, we're looking at the model training aspects of it, data engineering aspects of it, and also the pipelines, the data pipelines that we might use to kind of bring that together. On then moving on towards the near edge, we are looking at perhaps maybe when a model is deployed, is there a model registry? Can we monitor and observe these models that are running in, for example, in case of a far edge model as well. So there is this possibility to distribute the AI components across your infrastructure rather than keeping it just in one beefy area. Obviously, the further you go on left, the less possibilities you have based on the hardware and the software that needs to run on it. But the further you go right, you are going towards more enriching that process as well. Again, reading the device edge, getting the data into it, the telemetry, all of this is also important in order for us to take that information back towards the right as well. So it's sort of like a mix of components that are distributed and that are flexible towards how you deploy your application infrastructure. When we talk about, I think it's fair to say at this point is that when we're operationalizing AI and ML, we have these different team players that are out there that are part of this complex process, and some of these are already in-house, and some of these expertise that you are able to use. But obviously, there are AI specific activities that you might want to use as well. But if we start to sort of like go into exactly the different areas that needs to be done from a business leadership, you're looking at obviously the KPIs, the goal setting, but then from a data engineer perspective, you're looking at gathering and preparing that data. From a scientist perspective, you're looking at how the model is developed. And then further with ML engineering, you're looking at not just from development, but also integration and integrating into application development and monitoring and managing as well. So it's important for not just keeping this towards engineers and scientists, but also towards ML engineering and ML ops as an example. So IT operations can take that ML ops and platform engineering roles where they can bring in this together and serve, for example, for the larger population that is application developers or function developers as well. From an OpenShift AI components, it sits in with all the different blocks that I just shared. When you're gathering and preparing data, tools like eventing, AMQ streams, etc., that we are so used to already are also possible. And then obviously towards, whether you use TensorFlow, you use PyTorch, you use ONNX, whatever model serving you use, you are able to do that. So OpenShift AI, for example, gives you that possibility while integrating with other things like OpenVINO, Starburst, etc., and giving you that option to be able to provide a more ML ops experience together with the underlying infrastructure that sits under OpenShift. It also integrates together with our partners, with ISV ecosystem, so you're able to leverage that as well. So that's just the ecosystem part of it, but it's also, like I mentioned in the beginning, it's one of the core pillars of seeing that we have a trusted system that actually expands together, providing those possibilities. But that's not just all, right? So when we talk about model training, we want to make sure that it supports a variety of use cases. It gives performance and scalability. It initiates the possibility for you to just not do single node clusters, but multi-clusters, etc., for batch training, and has the performance needs and automation that it needs for that. So if I look into that division again, for gathering and preparing data, you're looking at data storage, data lake, data exploration, and most importantly, stream processing. And then from tuning, we're looking at foundationing models and pipelines, which I will just come into in a little minute now. And then finally, CI/CD, which is extremely important. How do you make sure that your model is able to go through the CI/CD process and retrain your model and deploy that together with your applications as well. And finally, visualization, that is also an important piece in this as well. So distributing workloads, enhancing the efficiency, you are looking at focusing on modeling and not infrastructure. So underlying platform should provide that dynamic allocation of your compute power. So whether you're using containers, in Kubernetes, you need that to be able to scale, to be able to have distributed jobs and executions, automate that setup, and then obviously streamlining your data science workflow as well. A simple process would look like configuring the distributed workload clusters in a more simplified manner for data scientists. You're able to create those requests. You're able to aggregate the resources together, and then you're able to dynamically scale them as well, to be able to submit the jobs and send requests to the system, whether you're creating, deleting, adding into your model, etc. As well. From the open source perspective, the OpenShift AI has all the OpenShift components, open source components, whether if you're using things like Kserve, if you're getting models from Hugging Face, Onyx, etc., you're able to do that, and it will help you to serve those models together, ensuring that you are able to have a data pipeline to do that as well. So using the model service interface, choosing and scaling through those resources is also important. So here's a screenshot where you can easily select the required resources, you can deploy them, you can kind of give your models and how they should be served, all of that information into the OpenShift AI as well. But what's also important is that you're able to have a pipelines component where you're able to gather the data let's say through eventing like AMQ streams. You're able to process that data, for example, using things like Camel or something like Mule, and then able to train that data inside your machine learning environment, and then be able to compare and push that continuously as well. The ability to schedule and track those pipelines is also important, and then further to chain those as well as you go along. From a Red Hat OpenShift data science pipelines, you see a user interface where you will be able to, kind of go through these processes together, and again forming that MLOps experience on top of Kubernetes, as you would say. What's also important is something to note is like when you start to integrate the applications together, you're bringing in, as an example, the source code, the cloud native applications, and you want to be able to make sure that security is also part of your pipelines. So ensuring that you have trusted content, that you have the right SBOMs, as a bill of materials, software bill of materials that you want to use them in building your artifacts, and then obviously able to monitor them as well. And a pipeline run would look at, how you can clone your repository, how you would build them and create a container out of them, and then be able to scan the containers repeatedly through security checks, etc., and ensure that you have the right kind of signed binaries that you are using with your artificial intelligence systems as well. What's important is that you are able to consistently deploy and manage these applications. You're able to monitor them and obviously automate them across the edge as well. Once you are looking into that step process and operationalizing your artificial intelligence, you also might need to think, okay, I have cloud native developers. How do these cloud native developers work with enhancing my model and enhancing my functions and applications? So you're able to bring in things like security, the authentication and authorization process into creating your applications with a self-service environment like Red Hat Developer Hub, where you're able to add your GitOps practice, you're able to add your templates for your cloud native functions, you're able to connect to registries, you're able to go through the pipelines that will have the security, and also be able to have a trusted content pipeline that integrates together into one single interface, where developers will be able to develop from and use the artificial intelligence model as they go along. Furthermore, if we look at this sort of like building block process, you're again looking at, okay, we have the artificial intelligence, MLOps system, which is managing our life cycle, which is doing the model serving, which is, having our pipelines, etc. But then being able to give the developers a developer platform, able to have a secure software delivery, so trusted content basically with your software bill of materials, the ability to connect networks, or application networks within, let's say, layer 7, to fetch data from each other or to form meshes and clusters as you do to get together on, for example, in case of edge, you're able to connect these functions together on that level. Then finally, obviously, there's also tools that you might need for modernizations or through Gen AI use cases where you're able to migrate certain old code bases. For example, if you were migrating from Java 17 to Java 21 or certain versions of libraries, you're also able to use Gen AI use cases where you're able to get the new code or the enhanced code that could help your certain functions as well. And then finally, building cloud native functions, the tooling for it, whether it's within Java, whether it's with Node, whether it's with Rust, etc. The ability to have that, the right environments and frameworks to do that are small footprints and easier to deploy as well. All together within a layered experience where you have infrastructure operations as well as developer tooling meshed up together to help you. If you look at the overall picture that we just sort of like explained, is that you could have business components that are running on your edge, and whether it's video systems, whether it's robotics, manufacturing, having the possibility to connect them together, let's say with something like the Red Hat Service Interconnect, which is connecting on a layer 7, creating those on-the-fly meshes and in a network that you might need, but also the possibility to have trusted content or cluster security, which basically looks at your containers, enhances that experience by saying, okay, is it secure? Does it have certain vulnerabilities? All of that together, but then also having possibility to automate them through, let's say, Ansible, event-driven Ansible, where you are able to listen to certain infrastructure events and create the Ansible playbooks to roll out those changes within the edge, as an example that you need. But then connecting all of that together with data science, with OpenShift AI, to enhance your telecom functions to be able to do it, and also give that data out to your partners as well. All in all, forming that infrastructure that will help you to operate between core and edge and distributed in those different components across the different parts of your edge. With OpenShift, you get the possibility to sort of like reduce this risk, be able to use these components within OpenShift more seamlessly within the pipelines, and have a more sustainable and power efficient solution, as you would say. So here I will stop and I will come back to you, Tiffany, if there are any questions that I should take at this point, or have I just ran over time?
Hello. So we're very nearly out of time. Shaf, thank you. You covered an awful lot of ground there. So Anne is asking about bringing AI to the edge, and is it really economically viable? Because obviously AI requires a lot of compute power. And as you said yourself, the edge can be quite a remote place sometimes, but it's not like the sort of data center situation we're used to. So is it just too expensive to have that at the edge?
Well, it depends on the certain use cases. If we look at use cases today, some use cases might need more power and consumption, and obviously that will keep a blockade for us when we go towards the far edge, right? But maybe it's video or specific inputs that needs a lot of devices that are sending it. Then obviously there can be issues. So what I showed earlier as well is that you distribute your edge components. You don't put the entire AI infrastructure all the way in, but you actually have to play a little bit smarter with how you will distribute your MLOps, as an example. Like your model serving could be in one part of your edge, whereas your events and your retrieving systems could be on the other side of the edge, as an example. And then the core training and data science model could be totally towards the core. So it's more how you split. And obviously, which use cases you are looking at is the key distinguishing factor at this point.
We have another really good question, but we're on the verge of running late. And this is, so could you please be brief, Shaf? I'm sorry, but have we got a case study where either the top or the bottom line has been improved by AI at the edge? It might be slightly early days.
I think that's a very good question. I'll try to
measure it as well.
I'll quickly take it. I think that the financial impact is still yet to be sort of seen at the masses at this point. I think, yes, the opportunity exists. The technology exists, but I think the large rollouts are going to tell. And I think the future, if we look at it from a compute power, etc., is definitely going towards that direction. So it only enhances it at this point, if I'd say.
Shaf, many thanks indeed.